Hi, how you doing? Today we'll be documenting how to calibrate my electric constant pull racket string machines, tension calibration. The machine that I have is a Pro Tomcat. So far it's been pretty good to me. However, recently I was able to find the only instruction on how to calibrate the machine from someone who posted a list of instructions from Germany in German. He had posted on the Talk Tennis forum site. So I went ahead and I translated the instructions to English, and it was pretty simple. It's a 7-step process, and I repeated it quite a few times, and I think I'm pretty good at it now. So I'll go ahead and explain how I will go about doing it. This is the digital scale that I'll be using. It's meant for fishing. It's down to 2 decimal place precision. It has a lock function which can be used. I don't use it because what I find is that the readout on the tension head could still fluctuate, and I want my weight scale to be able to simulate or follow that fluctuation as much as possible. Because after all, the instrument that you'll be using to calibrate something out should be more precise than what you're trying to calibrate. So this thing right here can be easily hooked on to 3 different locations. It can be hooked over here, or you pull the tension all the way to the tension head. This will simulate the longest pull from the 12 o'clock position of the racket head. So from my experience the other day trying to do this, what I find is that the distance, the pulling distance, in this case, is the longest you'll ever have to pull versus, for example, if it was turned 90 degrees and you're pulling the longest cross string or even the shortest cross string. This will indicate the shortest case scenario. So the distance, the pulling distance does affect the final tension pull that's measured on the digital scale. So what I find is that the longer distance will contribute to a lower tension being pulled. And therefore, if your interest is to have the final racket tension to be most precise, or in other words, the highest as possible, you want to calibrate it at the longest distance as a worst case scenario, because once calibrated from the longest distance, all the shorter distances you might overshoot a little bit. From my observation, the difference between the longest distance to the shortest distance, at least from my experience and on this tension head, is approximately half of a pound. So in the grand scheme of things, the end result of a half-pound difference may not matter as much. Keep in mind that this reading is obtained from pulling one single string. However, after we had done stringing the whole racket, you're talking about at least 18 mains plus, I'm at least 16 mains plus 18 crosses, all interwoven together. That sort of will average things out quite a bit. So the end result tension difference should not be more than half a pound, in my mind at least. I haven't done an experiment to prove that, but logically speaking, that's been my observation. And from watching the YouTube Albert Lee's video on YouTube, the way he does it is he uses a similar scale. It's not the same exact model. What he does is he'll mount it right here and pull the string from the shortest distance. So as I mentioned before, when doing it this way, the tension that's pulled is going to be on the lower end. There's also some people who have turned their turntable 90 degrees, locked it, and they use one of the base clamp. I could use this one, hook it up to that, pull it from this location, or you could choose the longer side, which is the opposite end. And you could literally simulate pulling from this location, which happens to be against the left side of the rocket frame approximately. It would simulate a realistic situation of a longest pull of a cross string.